Inshallah, we will discuss how to make the bottom plates by using another feature in SEG. This feature is more flexible, give you more flexibility to control the dimensions of the bottom plates or roof plates, in case if you have a flat roof or flat bottom. Okay. After that, we will open the project of the previous training day and add some nozzles like manholes, other nozzles with internal and external projection. After that, we will proceed with the fabrication drawings shown. Okay, now let's discuss one thing we would like to present today, which is how to make a bottom plate, okay, with a random arrangement. Okay, as you can see on the bottom plate and roof plate arrangement tool, you will have the ability to get the arrangement of the plates in arranged pattern. But if you have some not arranged patterns and you would like to give different thicknesses for the bottom plates and give different arrangement. Like here for that sample, for example, you have a small plate here, another one on the same side, and besides them you have another plate along with both of them. So and on the side here you have another one with that as a longitudinal plate. So how to make something like that and how to control. Okay, now let's create a new project. And select a location for this project. And let's click on finish. Now SEG creating the project details. And from here, when you select the vessel node, let's select the head type. Okay, we will not select one of the API elements. We will select the head type. Okay, and when you select it, you will find here more than 17 types of different type of heads. We will select the last one, which is circular flat end from random blades, and let's define the dimensions of this circular bottom blade as, let's say, 10 meters. Okay, so we will have 10 meters diameter for this head, and the main thickness will be 10 millimeters, and we will keep the start lab and end lab equal 0 and click on save. Okay, now when you select this type, you will find here a child. This is a child. We will use it to add the random blades. From here, let's add random blades. And when you select this one, this child, you will be able to add an arrangement for blades. Now you have up to 10 items. You can 10 different blades. You can add them to this child. If you would like to add more blades, you can add a new child to the same head to add the number of blades per this head. So how to define the elements or the blades in this type of bottom. Okay, now let's create a new part to discuss how to define the dimensions. Now let's draw a circle with 10 meters diameter. Okay, like that. Now we have this diameter of the bottom plate, and now let's select a rectangle here with that type, which is the rectangle defined by 2 points. One of them is the center. So let's select this one and define that one like that. Now let's define the height of this plate. Let's make it 2 meters. Sorry, I make it 200, so 2 meters. Be like that. And let's make this line tangent to that line. Now let's make another square tangent to this circle from the outside, like that, and convert the lines here to construction lines, like that, to show you how to calculate the location for each element. Now that's the first element. We will generate it on this one, and let's make this circle with a yellow or make it green color. Okay, so the main plate here, which is the middle plate, with a width 2 meters, and the width will be, let's say, 10 meters, no problem. But how to define the location of this plate? Okay, here you will find the longitudinal welding line orientation. We will keep it 0 right now, but the thickness here, you can make each plate here with a different thickness if you would like to make it with a different thickness than the main bottom plate thickness, or you can keep the same thickness of the main bottom plate. Okay, here regarding the length, if you take a look to the image on the right hand side, so let's take the screen here and make zoom. Here, for example, to define this plate, here, to define this one, here you have the data point, which is 0 and 0. Okay, so to pick that point on that element, so the location of this point defined by X here and Y. Okay, so each plate we will define it by the location with X and Y. So from this one here, we can define the location from here to there, it's equal 0, but Y here is 4 meters. Okay, so we will define the first one, so the here the location will be 0, and location on Y direction will be 4 meters. Okay, regarding the length, here we have the length of this plate is 10 meters. So let's define the length here to be 10 meters, and the width will be 2 meters. Okay, so by that way, we define this plate dimensions and the location. Here, the length and the width of the plate, and here the location based on the reference point, which is the green point here. And you define X and Y direction for this point. Okay, and give a material name for this one. Now let's define another plate. If we come back here to this one, let's define another plate here and make this plate at the middle here, and make this one tangent to the circle at the top, and we will make the midpoint here on this line located vertically to that one. So we will select this midpoint and make it vertical directly to this one. Okay, now we will make an overlap here between that line and that line with 50 millimeters, and define the width of this plate to be 2 meters. Okay, so we have this plate like that. Okay, so now to define this plate, by the same way, we will pick this point, okay, and define the length, width, and location X and Y. So the length here will be 2 meters, okay, and the height is 4050. So from here, we will activate the second plate, give it the same thickness, and the length will be 2 meters, and the width, which is on the longitudinal direction, it's 4050. So you will define that like that. And the location, we need to measure the location of this point. So we will measure this point from here to there. It's 4 meters. So that's the location on the X direction. So it's 4 meters. And on the y direction, it's equal 0. So this point from that line, it's equal 0. So we will keep this value as it is. Now let's save this, and let's add another plate on the other side. So by the same way, let's add a rectangle here and make this rectangle tangent to this line. And from here, we will make the midpoint vertically with that one and define the overlap to be 50 millimeters. Define the width, let's say here to be 3 meters. Okay. Now let's define the location and length and width for this plate. So let's activate this third plate, and here we will make the thickness. If you would like to change it, let's make it 20, for example. And here the length will be 3 meters, and the width will be 4,050, and the location here. So the X location we will measure from this point to that point. It's 3,500. So the location in the X direction is 3,500, and on the Y direction, let's measure from that line to that line. So it's 5,950, like that. And now let's click save. Now let's test if we make this arrangement in a correct way or not. So let's click on assembly to start creating those 3 items on this bottom plate. As mentioned, SEG will create all elements in behind. So if you would like to make a rendering for the elements during creation, we can do that from the setting tab and open the application setting form and select child preview and parent preview. Now here we have that arrangement. As you can see here, this plate thickness is 10 millimeters. Okay, so we have those 3 plates. Now let's check the setting tab, and from the app setting, we will select the parent preview and the child preview. Those options will give you the ability to make a rendering for all childs during creation and for all parents during creation. And now let's click save. Now let's add some other elements here. Let's add another plate like that. Okay, and make an overlap here with 50 millimeters. Okay, and make the width of this plate to be 250 millimeters. Okay, now let's add this plate and define it. So here let's select plate number 4, and here the thickness of this plate and the length as we define here is 2.5 meters, 2,500 millimeters, and for the width it's 4,050. Okay, and for the X location, so let's measure that line from the data point here. It's 1,550, and for the Y location it's 0. Okay, now let's add another plate, which is the 5th plate. By the same thing, we will do another plate here and make the overlap here equals 50 millimeter. And now the width of this one will be 1,600. So the length will be 1,600, and the height will be the same, and the location will be at 0 and 0. Now, if you click on save and try to run the assembly to start creating the other 2 elements, okay, here that's the 4th part. Okay, so by that way, as you can see, Here we defined the another two plates with an overlap like that. And by the same way, we can do the other plates. So let's complete this one, but on the we will make something little bit different here. Let's add another plate here to be like that. Okay, and let's define the overlap to be 50. Okay, and the width here we will make it 3 meters. Okay, so we have a plate here with a width, that width, the length, sorry, which will be defined in on the elements. It's 4050. So let's activate another one. So the length will be like that, and the width will be 3 meters. And now let's measure the location. So the location from that line to that line. So the x is 5,950. Like that. And the y location from that line to that line, it's 1,050. Like that. And now let's add another plate here, which is a plate from here to there, and make the overlap is 50 millimeters. Okay, so the length will be the same, but the width will be 1 meter like that. So we will make it's 1,100, and for the x location it will be the same x location. It's 5,150, and for the y location it's equal 0. Okay, now let's click on save and create the other two plates. As you can see, SEG will go through the previous elements to check if there is any change on the dimensions of the previous plate or plates or not. After that, SEG will import the new elements on this bottom plate. Okay. As you can see here, you will find more flexibility in making a patterns of plates. Okay, you can make some longitudinal plates here. You can make some plates with a horizontal orientation beside another one with a vertical orientation. So here you can customize the configuration of the bottom plate as you would like. Now let's add some other plates here. So let's add another one from to the end, 50 millimeters here. So that plate length will be 3,550. So let's add this plate. That's the length, and here the width from here to there. It's 4,050, and the location from x direction it will be 0 because this line is here, and for the y direction it's 5,950. Okay, and here let's add another two plates. So from here let's add a small slice like that and define that width to be 50, and for the length it will be 1 meter. Okay, so from here so the height will be 50. So that's the width. Let's activate this one. 50 that, and the width is 0. And for the x location, so we will measure from here to there. That's the x location, 6,450. And for the y location from here to there, it's 5,950. Okay, and finally, let's add another plate here. Okay, from here to there, and define the overlap to be 50 millimeters. Okay, so the width, the length of this one will be 2,600, and the height be 4095. And for the location, so the X location will be 7,400, and for the Y location, it's the same of the previous two elements. It's 5,950. And now let's click on save to generate the other blades on that one. As mentioned, SEG will go through the previous parts, because if you have any change on the elements, so you should, SEG will go through them and modify if you have any. After that, SEG will start creating the other new blades. Here we are modifying that one. Here you will find update icon here. Now the new blades will be generated. Okay, so now as you can see, we have the blade arrangement for the bottom or for roof blades by using this technique or this type of elements, which is adding a head, and this head type should be circular flat end from random blades. Okay, and we can add a child for it. This child is a random blades child, and from this type of a child you can add some random blades. You can add any number of childs for random blades. For example, if you have 30 blades on the bottom, so you can use 3 childs. Each child has 10 blades, so you can add any number of blades for the bottom blade by using this technique. Okay, now let's check the bill of material here. Now you will get a detailed bill of material for this type of head. And here, as you can see, you have the description, and here the technical characteristics, which include the actual length and width for each blade. Okay. So by this technique, you can generate this type of blades on the bottom. Now let's check how to make a nesting for that. Now we have an assembly for the blades, so you can open the assembly of the bottom blades and make a nesting study. And from the nesting study, let's select standard millimeter. Okay, as you can see here, we have one blade with 20 millimeters and the other blades with 10 millimeters. Let's accept that. And click on save. Now let's check the material categories which appear here. So here that's the available dimensions. So you can define the length. Let's make it 12 meters by let's say 3,200, and the same here. Be like that. And now let's click on OK. One more thing I would like to specify here, for the blade category here, you can adjust the frame width and the item separation, which is the distance between each item. So you can control the gap between each item during the cutting. It depends on the material thickness and the capabilities of the cutting machine. And here the frame width, which is the first element gap from the edge of the blade. So you can make it 0 if the cutting machine can do that. If you can define this frame offset with 0, as a cutting machine, you can do that. If not, you can define the right value which suits your cutting machine. Okay, now let's click on OK, and from here, let's create a new study, and from here, let's select a minimize lens. You will find the 3 different ways to define the arrangement. So you can optimize the arrangement to make it along the width and keep the remaining empty area on the lens side, or you can make your arrangement. I hope this image is clear. So let's take a print screen here and make a zoom at this area here. So for minimize the width, if here you have the length and the width, that's the length of the blade, and here the width of the blade. So you will make an optimization based on the width. So you will arrange all blades on the longitudinal direction and keep the width on the remaining area on the width. That's the technique of arrangement. Now, so by doing that, let's select the minimize lens and click on OK. And now the software of the nesting tool will make the arrangement of blades. So here you will get that arrangement for the blades based on the blade length that you give it to the nesting tool, the blade width and the frame offset and the item separation. So as you can see here, the item separation as we defined is 10 millimeters. So in between each item and the other item, you will find the separation value here between those. You have 10 millimeters. Okay, now I hope this type of heads is clear now. As you can see, you can make a random arrangement if you would like to use that. And now let's close this and open our previous project. So from file and open, let's open the project file, which is that one. That was our previous project. Okay, so when we open it, as you can see, you will find on the roof some elements goes outside. That's because the level of detail. We mentioned that you should select the correct level of detail. So from here, let's go to the representations, and from the level of detail, let's select the level of details that we create for the roof, which is roof details. So any other elements will be freezed. Okay, so now we have that model of the tank. By the way, our development team update this type of stiffening ring. So now you can, we will make a new release by the next week. So inshallah, it will be available if you would like to test this part. Okay, here we have this angle as a flipped angle like that. So we make another modification here for this type of flange. When you select it, you will find here a list of different standards. So you can use the Australian standards or SEG L or European L or SEG L Imperial or JIS angles. So we add some different standards here, and here the list of parameters, and you can make it welded from edge. So we make some additional parameters here will give you some flexibility during the model creation. Okay, now let's add some nozzles to this tank. So from here, let's add a nozzle on the second can. Okay, so let's go to SEG, and from here let's select the second can, and from elements we will select the API nozzles with external projection, that type, which is shell nozzle according to API. So from here, let's name this one as N1, for example. And from here, let's select the nozzle type, if it's a nozzle from pipe or nozzle from blade. Okay, so let's select a nozzle from pipe and define the size of this nozzle. Let's make it 6 inches. And here the scalable of the pipe, let's make it 40. And from here, the type of the rebad. If you would like to add a circular rebad or a diamond rebad or a circular low type rebad or the diamond low type rebad, let's select the diamond type. And from here, let's define the thickness to be 6 millimeters and give a name for this nozzle, like water inlet. Okay, and from here, that's the material of the pipe and the location and the orientation. So let's keep it on 0. And here's the projection. Let's make it 150 and click on save. And from the set weld button, let's define the weld detail for this nozzle. Let's make it 6 millimeters and 6 millimeters. Dimension A, which is the fillet weld between the nozzle and the rebad. So let's make a print screen here and go down here. As you can see, dimension A, which is the fillet weld between the nozzle and the rebad. So from here, that's dimension A. Okay, and B is the fillet weld between the rebad and shell. So it's that value. So from here, let's save that. Okay, and now let's add a flange for this nozzle. So from here, let's select the external connection point, and from here, let's add a flange. So it's N1 flange. Okay. And from here, let's select a slip-on flange. So let's select this type of flanges. Select the rating and the size. And here, the offset of the flange from the end of the pipe. So let's make it 5 millimeters and click on save. Now let's click on Start Assembly to start creating this nozzle. And here, that is the slip-on flange for this nozzle. Okay. Okay, so here we have this nozzle, which is assembled to that one, and the offset from here, which is the 5 millimeters, which is the offset from the facing of the flange to the end of this one. Okay, and now let's click on save. Now, by that way, we add a nozzle with a diamond rebad to the tank with a defined level from the parent element. So we make the location of this nozzle is 600 millimeters from the data point of the parent element. So the 600 measured from the parent element. Let's make a quick drawing to check what I would like to say here. If we add a detailed view for this tank, like that. Here, what I would like to say here is the location of the nozzle measured from the start point of the parent element. So here that's the 600. It's measured from the start point of the parent, which is CAN 2. Okay, we add it on CAN 2, so the location will be defined from the start point of this CAN, not from the data point which is located here. Okay. Okay. Now let's add another nozzle with internal projection. So let's select can 5, which is the top can, and from here let's select nozzle N2. Let's add nozzle N2, and from here let's keep this nozzle as 4 inches, and from here let's select the rebad. Select the schedule 160. Let's make it 40. Okay, and the location of this one, let's make it 1 meter, and the orientation, let's keep it on 90 degrees, and the projection 150, and the internal projection we could keep it with that value. And for the set weld, as you can see, the weld detail here for this nozzle will include an internal projection. So if we take a print screen and put it here, as you can see, we now have 3 parameters, which A, B, C. A is a fillet weld between the nozzle and rebad, and here B is a fillet weld between the rebad and shell, and here another. Okay, for the third fillet, which is the fillet between the shell and the inside projection of the pipe, so it will be between the pipe and the shell from the inside direction. So now let's define that value to be 6 meters, 6 millimeters, 6 millimeters, and click Save. Now let's add a flange to the external connection point of this nozzle. So if we take a print screen from that and paste it here. Now, as you can see here for nozzle N1, if we take a look to the nozzle N1, you can figure that you have an external point only. But this type of nozzle has internal and external connection point. Okay, so you can add external elements and internal elements to this nozzle. Now let's add a flange to the external point. So we will select the external node of this nozzle and add a flange, which is N2 flange. And for this flange, let's select the type of the flange. Let's make it weld neck raised face, and define the size of this nozzle and the schedule of this nozzle, the same schedule of the pipe, and click on Save. Okay, now let's click Start the assembly to start creating the start adding the nozzle. Which is nozzle N2 with internal projection. Okay, as you can see here, this nozzle, which is nozzle N2, if we come back to the drawing here, and let's take another view. Like that, and measure the location of this nozzle. It should be 1 meter from the start point of this can. So let's measure it from here to there. It's 1 meter. So let's minimize the scale a little bit. Okay. So that's the location of this nozzle. Now let's add some attachments like elbow and a deep pipe along this tank. So how to do that? Let's select the internal connection point of this nozzle, and from elements, let's add an elbow from here. Let's select elbow, into elbow. From here, let's select the type of the elbow. You will find here a list of different types of elbows. So let's select a long radius elbow with 4 inches, and from here the schedule and the orientation of the elbow. Now let's keep the orientation as 0, and let's run to check where is the orientation of this elbow will go. After that, we can modify the orientation of this elbow based on the 3D model. So from here, let's come back to the drawing here. As you can see, the elbow direction goes to below here, and that's the correct direction that we need. But if you, for example, find it goes to the top, you can control the orientation of the elbow to make the orientation goes down like that. Now let's add a pipe after this, or after this elbow. So let's add a pipe from here. So from here, let's add into pipe 1. Okay, and from here, let's select this pipe and select the first type, which is pipe, and make it as 4 inches with the scalable 40, and the length, let's make it 500 millimeters. And let's add a flange after this pipe. So into flange 1, into flange 1. And from here, let's select it as a slip-on flange, 4 inches with offset 5 millimeters. Let's add a gasket between the 2 flanges into gasket. So from here, let's add gasket. Let's add another flange into flange 2. And let's make it looks like flange 1. Okay. So it will be the same type, everything, but we will make it flipped to flip the direction of the flange. And now let's add another pipe. So into pipe 2. And make it looks like into pipe 1. Okay, so it will take the same parameters, but here we will increase the length, so we could make it 4 meters, for example, and click on Save. Now when you click on Start Assembly, here we add the last part, which is the internal deep pipe. So let's come to the drawing. Now it's updated. Here we have an elbow, that one, and we have a deep pipe like that with 2 slip-on flanges with a gasket between them. And here we have this pipe. So we could increase the pipe length a little bit, so we can measure it from here to there. And we can increase this value with more 4 meters. So this pipe length, we can make it 8 meters, for example, and update the model. So let's come back to the drawing. Here, the internal projection of this pipe is increased like that. Okay. Now let's start creating or check the tables on of the bill of material, the nozzle table, and the other tables here. So from the nozzle table, for example, as you can see, we have here a clean outdoor. We have nozzle N1 and we have nozzle N2. And let's take a print screen from this table to discuss each column here. As you can see here in the first column, we have the tag of the nozzle. And here we have the service for each nozzle. And here the size in NBS size. So if you would like to make this size in DIN, for example, or a mix between units, DIN and NBS. So how to deal with that? Okay, so let's close this. And from the setting tab, when you open the app setting, you will find here an option give you the ability to control the format of the size of the nozzle. So you can make it in NBS or DEN, okay, or you can make a mix between NBS and DEN, so it will be in that format, NBS and between brackets the DEN, or you will find some different values. For example, if you make it NBS and between brackets DEN and click on save, now when you open the nozzle table here, and now let's take a print screen and make another image here. As you can see here on that one, the size will be defined in DEN, NBS, and between brackets DEN. So here for this nozzle will be 6 inches and between brackets 150, and for the 4 inches it will be 100 millimeters. Okay, now let's check that on the bill of material. So if we open the bill of material, here for the flanges, so let's take a print screen and create new one, and let's go down here for the flanges, for example, and seamless pipes. Okay. Here, as you can see, the size will be defined by that way. Okay, for the flanges and for the nozzles, it will be defined like that. Okay, so by that way you can change the way that you would like to present the size of the nozzle in the bill of material or inside the nozzle table. Okay, now let's complete the other information on the nozzle table. Here you will find the outside diameter, okay, of the pipe. If you have a standard pipe, you will get that those dimensions for the pipe outside diameter, and here the orientation of the nozzle and the thickness of the nozzle. Okay, and here the schedule based on the thickness based on the schedule. And if you don't have a schedule, just a defined thickness, it will be a dash here on the schedule tab. Sorry. For the flange class, the rating of the flange, it will appear here, and the facing of the flange, the type of the flange. Here we have a slip-on flange, and here we have a weld neck flange. And for the facing, it's a flat face. Here it's a raised face and raised face. And for the blind, if you have a blind, it will appear here, the class of the blind and the facing of the blind if you have a blind. And for the internal projection, if you have an internal projection, as you can see for the nozzle N2, you have internal projection with 200 millimeters, and the external projection, and the bad thickness, rebad thickness. And by the way, here for the external projection, it's measured from the vessel center line. As you can see, here we didn't define it on those nozzles. So here the can diameter, here is the can inside diameter 7,938. Okay, so if we divide it by 2, so that's the inside radius of the can. So if we come back here to this nozzle and open the calculator of the nozzle projection, okay, you will find here the default value is 2 meters. And if you take a look, so let's take a print screen, paste it here. So the projection of the nozzle measured from the vessel center line, so here to the facing of the flange. So this value is, as default, it's 2 meters. So you can figure that we didn't change it, so it's 2 meters here. Okay, so if you would like to modify that value, we can take a copy from that value or increase the projections that we would like to add, which is equal the thickness of the inside radius plus the thickness of the can plus the outside projection. So let's add here over this value, let's add the thickness of the can, which is can 2. I think the thickness was 8 millimeters. So let's close this one. The thickness was 8 millimeters. So let's come back here and open the calculator. And from here, we can increase 8 millimeters plus the projection, which is 1,500 when you click add. So that's the projection from the tank center line to the facing of the flange. So when you put it here like that, let's remove this comma and click on calculate. Now that's the projection of the flange. So let's click on save. Okay, and when you click start the assembly, I will sorry, I will reply for this call. Sorry. So from here, if we open the nozzle table now, so let's open the nozzle table. As you can see here, the projection, as you can see, it's changed. Okay, so that value will be measured from the vessel center line, but for the clean outdoor, it's measured from the outside surface of the tank. Now let's complete the other information here. So if we have a bed, so the bed thickness and the bed width will appear here, and for the weld style, and here's the parameters of the welding, parameter A, B, or C, and finally here that's the main attachment element. It's attached for the CAN 1, CAN 2, and CAN 5. So that's the details inside the nozzle tape. Okay, now let's check the bill of material. When you open the bill of material, you can find that you have the bottom plates appear here, and here the annular plates, and the shelled cans, and the seamless pipes, the flanges, elbows, all of that, it will appear. Okay. So now, if you would like to use your custom drawing, okay, let's say we need to add a standard template for our projects to SEG to use it each time we will generate a drawing, like a general arrangement or a detailed drawing. We need to use custom drawing generated. This custom drawing includes our template and includes our border, title block and border. Okay, so how to generate our title, our reference drawing, which include our title block and border. Okay, now we will need a standard drawing from SEG. That's the first point, because we will use this standard template to add our title block and border, because this drawing includes some tables like the nozzle tables, bill of material table, design data table. So if you use directly your own template, you will lose the ability to generate the other tables in your drawing. So here, let's take a copy from one of the SEG standard drawings. So let's take a copy from one of those. So let's take a copy from this one. And let's import it here inside the project here, and let's open it here. Okay, the thing that we will do here, which is creating our template, our title block and border. So let's remove those title block and border from here. And from the drawing resources, let's create our own border. So from here, let's add a new border. So let's define a new border. So let's add something like that and define the width from here to there to be 5 millimeters, for example, 5 millimeters, and the same from here to there. And let's add a text, for example, here like that. And we could edit this text to make it on the middle. So the distance from here to there, it's equal that value divided by 2. And from here to there, for example, let's make it 2 millimeters. And if you would like to add anything else, like adding a line from the middle here to the middle there, so you will design your border as you would like. Now let's save that. So let's make it, give it a name. And now you can import it to the drawing by double clicking on it like that. So it will be imported to the drawing, or right click and insert. Okay. Before that, let's create a new title block. So from here, let's define the new title block. And from here, let's define the width to be 1,170. And for the height, let's make it, let's say, to be like that. And that's the main area, which is the height and the width. And now we can add some details, like adding some other rows. So from here, let's add one like that, and add some other tabs here. One for the revision. So here, let's add the revision. Okay, and we need to make this revision automatically updated from the drawing. So from here, let's add the sheet or the drawing property. And from here, you will find one of them is the revision number. So you can import the revision number directly to this one. So let's add. So here, as you can see, we add a revision here, and that parameter, which is between brackets here, will be automatically getted or calculated from the. Now let's add the location of this one. It's 2 millimeters, and from here to there, it's on the half of this value, or we can make it directly by align the center of this point with the center of that line. So you can get that, and let's define the width of this one. So let's make it 30 millimeters, okay, or minimize it to be 20. Okay, so as you can see, the text goes outside, but it's not a problem because the value here will be 0, 1, A, B. So we will not need all that. Now let's save that as Ergo. Okay, and now when you add the border, let's insert it. And for the title block, you will find something a little bit strange. Let's take a look to that area here. Let's import it, like insert. As you can see, the title block measured from the 0 point here. But actually, we need to move it to that point. So we need to make a little bit modification here, which is adding 2 lines here, which they will make the offset from here to there, which is they are 5 millimeters. Okay, and make them equal and give them, let's say 1 millimeter. And when you click save, now as you can see, the title block will move on that direction. Now, if you open the properties of this drawing, you will find here a tab for the revision. So when you make this revision as revision A, for example, and click close, you can figure that the revision value will be changed. When you change it to 0, for example, and click save, the value will be changed like that. Okay, so let's complete the modifying of this border. Let's decrease this value to be 15. And now let's add here another parameter, which is the sheet number. So if you have more than one sheet, automatically the drawing will include sheet, let's say 1 of 5, 2 of 5, 3 of 5. So how to make that? So from here, let's add a parameter here called sheet. Let's make this text on the middle, which is sheet number. Okay, and now let's add new parameter, which is from here. Let's select the custom, the drawing property. So from here, and here you have a number of sheets. So let's add the number of sheets. Okay, but before that, we need to add the sheet number before the number of sheets. So it will be the sheet number by the number of sheets. So let's add 1 here before that one, which is the sheet property, which is the sheet number. Okay, so let's add the sheet number. So here we have 2 values, sheet number by the number of sheets. So those are 2 parameters. We add them here, and we have this text. So let's define the location from here. It's 2 millimeters. And let's make this text at the middle of that line. So for any time you change this height, for example, the text will remaining on the middle. We make it 5 millimeters, for example, the text remaining in the middle of this line. So let's make it back as 10 millimeters. And now let's define the width of this one. Let's make it, let's say 30, and click on finish. Okay, now as you can see, the sheet number is sheet 1 of 1. Now let's create a new sheet. So if you add a new sheet here, you will find this sheet, which is the second sheet, is 2 of 2. And if we open the first sheet, it's 1 of 2. So by that way, you can add some parameters to the sheet. Okay, and let's delete the second sheet and complete our modification on this order. And now from here, let's let's add the drawing number, for example. So let's add the text here, and from here, let's add that one, which is drawing. Okay, and let's add a parameter here for the drawing. You will find that on the custom properties of the drawing. Actually, those custom parameters related to SEG. So you can use those parameters in case if you would like to use them. SEG automatically sends those parameters to the drawing automatically. So from here, let's select drawing number and import it. So by that way, you can add the drawing number automatically to the drawing and make this one on the middle of this line be like that. So if you click on finish, and here the drawing number is TBA, and if you change it from the custom properties, that's the drawing number. So that's the drawing number. For example, if you create it in SEG as SEG, for example, DWG-001, and you click modify and apply, close, automatically it will be modified here. So let's make it back as TBA and modify and click. Okay, so that's the drawing number. Okay, now let's add a logo inside this border, let's add the equipment tag and equipment service on this border. Let's add some parameters like the project name and some other things. So from here, let's edit this title block. And from here, let's add that one. And from images, let's add an image. So let's go here and go company logos. Let's ErgoPraxis, for example. That's it. Okay, so we can add this logo here. Be like that, and define the height from here to there to be 32, for example, or 8. Sorry. Something like that. Okay. Now let's add the project name. Let's add another line here. Line offset from here to there. Let's make it 20. And let's add here the vessel tag and the vessel name. So let's add the parameter which indicates the vessel service. So from here, let's select the custom properties drawing. And from here, let's select the from here the vessel name. Okay, so that's the vessel name and import it. And down here, let's add the vessel tag from the custom drawing. So let's add a vessel tag, and the third line, the drawing name. Okay, and make it like that. And make all of that centered. Okay, so we will center all of that. And we may need to increase the font size. So let's select them all and change the size to 3. Okay, and now let's align the midpoint of this line to be at the center of this line. Okay, and make that line from here to there the half value of that height. And you can make the spacing between lines for like 1.5, for example. So it will be like that. We could increase this value a little bit. Let's make it 24, for example. Okay, and click on save. Now here you will get the vessel name, the vessel tag number, and the detailed drawing or the drawing name. So if we make a check, for example, like on the custom drawing for the vessel name, which is that name, we can name it as, let's say, storage vessel, and click on modify. Okay, by the way, this value will be sent automatically from SEG, but we would like to make a testing for that, so the value will be changed to be a storage vessel. So let's make it again as a vessel name. The same thing will be with the detail or the drawing name and the vessel name. Okay, well, let's add another parameter like the project location here and find that as in millimeters. And from here, let's select the custom properties. Sorry, the custom drawing properties. And from here, you can add the manufacturer, location, part, number, plant name, or project name. So let's add a project name. And from here, select the size to be 3.5 and make everything is on the middle here. And let's adjust the text to be in the middle. And the location from here to there equals the half of that height. So that will be the project name. Okay, so by that way, you can create your own border and title block. Now let's save this. So from here, let's save this title block. And now the second step, which is how to use this border as our reference border in SEG. Okay, Any questions regarding this point until now?
No, we can proceed. I think everything is clear.
So from SEG here, and from the setting tab, and from the custom drawing, now we will define this border and the title block. Let's select the reference border. So let's go to the desktop. From here, let's select the location of the project. And here, that's the drawing. So we can take a copy from the name here and import it. Now let's give it a name like ErgoPraxis border. And from here, let's define the width of the border and the height of the border, which is, if you come here and make edit, which is that value. Okay, so that's the height, and here that's the width. Okay, so it's 5 millimeters. Okay, so if you take a look here, all values defined in the centimeter. Okay, so we can make it like that. So the height and width is 0.5 centimeters. Okay. Okay. Now for the title block, we will define the width of the title block and the height of the title. If we come back to the title block here, we defined it as 17 centimeters, which is 170 millimeters. That is the width, and the height is 9 centimeters, which is 90 millimeters. So by the same way, we will define the values here, which is 9, and here it's 17. Don't forget that all dimensions defined here in the centimeters. Now let's click on append. So after importing it here and give it a name and defining those values are very important. You can click on append. So now you can figure that this border appears here. Now when you select it and click on set as default, you will get this checkbox activated here on this line. You can add any number of title blocks and borders as you would like. If you have a different projects with different title blocks, you can add any number of borders and title blocks. Now this border and title block, the activated one. Okay. If you would like to delete it, you can delete it. If you would like to edit, you can just select it from here and modify the values and click on update to update the stored values for this title block. Now let's click on close the border, and from here let's create a new drawing. So from here, let's click on create drawing, and from this form you will find on the first tab, which is the sheet data, the size of the drawing. So you can select the size of the drawing from here, which is A1, and you will find the height and the width of the this drawing as a standard drawing. You can make the drawing as a landscape or portrait, like that. You can control the location of the border or location of the title block. So we will make it located on the right bottom side. And from the active views, you can select or you can add the required number of the views on the drawing. So for here, let's add a single view for that drawing. Okay, and that view, let's make it as the back view. So if we take a look from the back view here, that will be the elevation view for the tank. So let's save this and close it. Okay. So from here, let's select one view, which is the elevation view. And for the orientation of this view, what is the meaning of the orientation of this view? I will discuss that with you now. Here on the previous tab, we select that we have a single view, which is the elevation view. And here the SEG will ask you which view that you would like to make it as the elevation view. For that tank, for example, if you take a look from the back view, okay, that will be the elevation view. Okay, so if you take a look from the back view, that means you will make that view is the elevation view. If you look from this that one from the top view like that. So that will be the elevation view. Let's change the level of detail like that. So that will be the elevation view. Okay. So from here you will be able to select the view that you would like to make. So from here, let's select the back view, which is that one. Okay, the back view here will be the elevation view. Okay, now let's select the location of the tank on the drawing. The locations will be in the centimeters. So let's make it 30 right now. And the scale, let's make it 40. And after that, we can change it and make it make sense. For the tables, okay, here in this form, in this tab, which is tables and annotations, you can select the required tables in your drawing. So let's select the bill of material table, the design data table, the nozzle tables. Okay, and from here you can add some other tables like the pipe tables, gasket table, fitting table, and from the notes you can add general notes. Those are the default general notes. You can edit or, for example, if you would like to edit this one, you can just type what you would like to edit here and modify. And if you would like to add other notes, you can add them like that. So you can add notes or delete notes, and you can import notes from an external Excel sheet. You will just write that on a separate cell, okay, on the sheet, and you can import that Excel sheet directly to here. Now let's discuss the welding details. Here, that's the library of the welding details. So you can select from the SEG standard welding library. So let's discuss the components here. You will find a weld detail for a single V weld, for the circumference weld, and for the longitudinal welding lines. And here the weld will be to the outside. But if you would like to make the weld for inside, you will find here some other details for the inside weld. Other welding details for including the cladding and the weld overlay, and as a double V, not a single V. It's some other details for double V, and some other details for if you have a conical connection with a shell. Other details for the flange welding with the nozzle, okay, with a single V or a double V, or if you have a clad. If you have different thicknesses, like if you have an insert blade with a can, so you can use that, or if you have a forged hub with lips with a shell, so you can use those details. Sit on flange, and the welding of the sit on flange, so you can select the suitable case. Let's select this one. And if you have an elbow, if you have a nozzle without a reband, or if you have a nozzle with an enforced reband, as you can see, different details here. So let's select this one. Okay, and the nozzle with internal projection with a reband. So let's come here and select this one. Okay, so it's a nozzle with a reband with internal projection. And you will find some other details, like if you have a reband welded to the shell for platform clips or something like that. And you have some attachments, and for the bottom, and a detail for the bottom plates with the annular plates, and if you have a sketch plate with the annular plate. So you can select the required welding details here, a detail like that for the annular plate with a different thickness with the other annular plates or the bottom plates. And if you have a tube sheet with a tube with a tube sheet connection, so you, after selecting the required welding details, you will click on save. Okay, and from here, the title block, we will give a name for this drawing as a general arrangement. And here for the document number, let's give it a name. Like that. And from here, let's define the revision table. So let's select this table and click on edit. This line is revision 0 and it's issued for you. And here it's prepared by, and click on save. Now, if you would like to add some empty rows for the revision table, you can do that by adding and click on save. So you will have some empty rows here. For the design style here, as mentioned, you can make more than one sheet in your drawing. For example, for this tank, we may have not more elements right now, but if you have a huge tank with a lot of elements and you would like to separate the some tables to another sheet, like adding the bill of material table to another sheet or adding the nozzle table to another sheet, you can do that by selecting the number of sheets that you would like, sheet 1, sheet 2, or sheet 3. Okay, and from here, for example, you can move the bill of material table to another sheet and click on save. Okay, but right now, I think everything is okay. No, not more. We don't have a lot of elements. So let's click on save. And from here, let's click on create drawing. So SEG will start creating the drawing using the, as you can see, we use the border and the title block of SEG. For client form. So let's here complete that one. That's the revision table, and here the bill of material. As you can see, every table will take place automatically. And if you would like to change the table location, you can do that. And anytime we will make some changes by adding other nozzles and make a reflect for that on the bill of material and inside the nozzle table. Okay, as you can now that it's the step of adding the welding details. Okay, as you can see, that's the first welding detail. After adding the welding details, we will discuss how to add the new items and how to modify the bill of material and the nozzle table for the new item. Okay, now let's check this here. That's the name of the tank. We change it to storage tank. And here that's the tag number, which is the equipment tag. And here the name of the tank. And here the project name, we didn't change it. It's still TBA. And here the drawing number, which we modified in SEG. It's automatically reflected here. And here the number of sheets. And here it's division 0. So, for example, if you would like to change the project name, let's go to the project information. And here for the project name, you can change the project name. Okay, and it will be automatically, when you regenerate the drawing again, automatically this parameter will be updated. So let's change it to that name, for example, and click on save. Okay, and when you click on, let's change some other parameters, like the name of the tank. It's a storage tank, so from or keep it as it is, no problem. So from here, let's update the drawing. So when you click on create drawing and create drawing like that, as you can see, the project name changed here. Okay, to New Cairo, Alexandria. Okay, so now let's discuss how to add a new element, like a new manhole, a manhole to this tank. and how to reflect that on the bill of material inside the drawing, and how we can reflect that on the nozzle table. Okay, so that's the next step. Here, let's select CAN 1, and from the elements, let's select nozzle according to the API here, and make it as M1, and click on Save. Okay, and from here, let's select a nozzle from pipe or a nozzle from plate. It's up to you. Now let's select a nozzle from pipe and define the size to be 24. Okay, and select the schedule to be, let's say, 80, sorry, 40. Or we can make it less than that, 30, for example, or 20. Okay, and from here, the name of this or the service of this nozzle will be man. Okay, and let's add a diamond rebad for this one with the thickness 10 millimeters. And here the location. So let's check the height of this one. It's 2 meters. So we can make this manhole on, let's say, 1 meter, for example, or make it 700. And instead of making a diamond circular or a diamond rebad, we will make it diamond low type. Okay, so we will make it diamond low type. And here the minimum value of the low type for 25 inches. If you take a look here, let's take a print screen. Here, those are the standard values as per the API. Okay, for the pipe OD. Okay, so that's the low type value. So this value should be greater than that. So I make it 7 meters. Sorry, I need to change that to 700. Okay, and now let's make the projection 150 and the orientation 170, and let's click on Save. Okay, now we have this manhole, but without any flanges yet. So let's create this manhole like that. And here that's the bed for this manhole. Let's take a look from the other side. So that's the manhole. Now let's add a flange and the gasket and the blind. So from here, let's come back to this point. And from here, let's add flange, M1 flange, and make it as a Wildeneck flange, 24, the same schedule, which is 20. And let's add a gasket. So from here, let's select M1 gasket. And now let's add this type, select the size, define the material if you'd like to change it. And from here, let's add a blind, M1 blind. By the way, you can use the API flanges. You will find here a type for the API, but right now I'm using the ASME flanges and make this flanges a flipped flange. Now let's add a bolt to this blind. So M1 bolt. Okay, and from here select the size of the bolt, the length, and the spacing between knots. And now let's add David, but let's discuss that after creating this, the other elements of this one. Okay, those are the subbolts. Now we have this one. So let's remove the UCSs. Here we have this manhole. Now let's add the manhole David, okay, to this manhole. So from here, let's select the blind flange, and from the elements, you can add a detailed manhole David or a single part manhole David. What is the difference between the manway David and that type, which is manway detailed David? I think it's appear from the name. Detailed manway David, this type will give you the ability to make the manhole David as separate parts. Each part has a description inside the bill of material. So if you for example, if the manhole David includes, let's say, 12 elements, those 12 elements will appear inside the bill of material. Okay, so that's the detailed manway David. Okay, and for that type, which is manway David, this type will give you the ability to add the manway David as a single part. So all elements will appear inside the bill of material as a single part. So the decision for you, if you would like to make all parts appear, so you will select a detailed manway. So in that case, let's select a detailed manway. So it's M1 David. And when you select it, you will find some specs for the manhole details, like that detail, that type of the manway, for that type, for the horizontal vessels, and for the vertical openings, you will find another specs like that. And for the hinge, manhole hinge, you will find a detail like that. Okay, so it's related to standard specs. So if you would like to make a modification, so let's select this one. From here, you can select the rating and the size of the manhole, and automatically all of those parameters will be calculated automatically from the database. But for example, if you would like to make some modifications, from here, when you click on select user defined, those cells will be open to modify. So you can change the dimension A, dimension B, based on the drawing on the right hand side here. That's dimension A, dimension D, dimension B, dimension C. So you can modify that. And if you would like to keep the standard dimensions as they are, just accept that. And from here, you can click on save. And here, that's the hand grip dimensions. So that is the rod diameter, the rod height. And when you click on start the assembly, the manhole hinge will be items, they will be generated. If you take a look to the inventor tree on the right hand side, you can figure that here we have the first element, and here the second element, the third element, which is the rod. So as you can see, each element will be generated separately as a new part. And here, as you can see, here we have this hinge here of this rod. Okay, it will be like. Now, if we take a look to the nozzle table here, we will find that we have a new nozzle, which is M1. But if we take a look to the drawing, this drawing, the 3D model or the details will update, but the nozzle table still as it is. No updates here for the nozzle table. And for the bill of material, as you can see, we have 39 elements. But if we open the bill of material now here, okay, and take a look here, we have a 51 elements. Okay. So we have now a change on the bill of material and a change on the nozzle table. How to reflect that to our drawings? Okay. So to do that, we will need to make an update for the drawing. We can do that by right-clicking on the vessel node, and from the drawing, we will select Create Drawing. And from the tables, we will do one thing, and it's very important here, which is selecting this checkbox, which is Update Tables Automatically. This checkbox will make a loop to select the selected tables here and update them. So be sure that you are not selecting not required table. We need to update the bill of material table and the nozzle table only, no other tables, to avoid consume the time in updating tables without any change. So those tables have some changes, like which is the bill of material table and the nozzle table. So during the updating of the drawing, we will select this checkbox, which is update tables. And when you click on create drawing, automatically SEG will detect that the bill of material table, as you can see here, SEG will remove the previous information and will fill the data again. Okay, the same thing as you can see on the nozzle table. Okay, now both of the bill of material and the nozzle table updated. Now we will need to move this table a little bit up to avoid intersecting with the revision table. Now we have the 51 items here. And if we take a look to the manhole, it's appear now on the bill of material. Okay, I hope until now everything is clear for you, because I would like to discuss some things here, and inshallah next week we can complete with another training day. Okay, I hope that you get a chance to try what we discussed on the previous training day. Did you get
Everything
a
is
chance?
clear. We're working on it. Yes, we tried one tank here. Irini has tried one tank. Well, we have some questions. First of all, sometimes the inventor model is not orientated we see from the top view the left view, if I said correctly. It's not orientated correctly, and sometimes this creates problem with the nozzles.
Okay, so
How we
let's
can
make this
fix it?
point. No, I think you will need to understand the correct way of the orientation, which is SEG and Autodesk Inventor can do. So from here, let's open this one and come down here to discuss the orientation of the vertical vessels and horizontal vessels. For the vertical vessels, to get the correct orientation, you should take a look from the top view, and as you can see, the top text is flipped to be the front to be here. So 0 degree will be at the front view, okay, and so that means the 90 degree will be on the left view, and the 180 will be on the back view. So that's the top view. If you let's take a print screen here and come here, that one. Now let's define the let's remove this one and add a text here. So that will be front view. Okay, if you take a look from the top view by that way, and here at that's the back view. Okay, and here that will be left view. And here is the right view. Okay, now let's apply that on the current tank that we have. Okay, so if we take a look from the top view, so let's take a look from the top view and make this text as a flipped text like that. Okay, so let's take print screen and open a new one like that. So if you are looking from the top view by that way, so that will be a 0 degree, okay, and that one will be 90 degrees to 270, and that will be 100 degrees. To apply that on the vessel, here that will be the 0 degree, okay, and that's that one maybe 135 maybe, but let's check that from the model, and that one it's 180 degrees, and finally that one it's on 270. Okay. Okay, now let's open the drawing and create a new view for that tank and discuss the orientation on it. Now let's open the drawing. Here we have that drawing. Let's create a new sheet. Okay, and from here let's add a top view. But as you can see, top text is not flipped. We need to flip it first, like that, to be like that, and make it as a top view for tank. And the scale, let's make it 1 to 20, for example. Okay. And before that, let's check an important point, which is the level of detail. So from here, let's open this one again. And from the level of detail, let's select roof detail instead of master detail and click on OK. So now we have that detail for the tank, and we could hide the hidden lines. Or if you would like to keep them, we can keep them. Now let's check the orientation of the nozzles. We have that orientation. Now we have this nozzle, so let's add a nozzle tag from here. That's the flange of the nozzle, I think, M2. Okay. And here we have another flange, which is M1. Okay, so let's come back to SEG and check the orientation. Here for a nozzle M2, let's select nozzle M2. As you can see here, the orientation on 90 degrees, okay, which is the same orientation that we discussed here, which is the 90 degrees, that one. Okay. And for the manway, we come here to the manway. You will find the orientation is 270. So it's in 270 as mentioned here, sorry, which is that one. Okay, and for the top view, this nozzle, which is N1. So let's come and select nozzle N1. It's on 0 degree. As you can see, this is the orientation. So nozzle N1 on 0 degree. And here for the clean outdoor. So let's go back to the clean outdoor and check the orientation. It's 135. Okay, and if we measure that from here, so let's add a center line for the clean outdoor and measures the orientation from here to there. It's 135. So I hope now the orientation direction for the horizontal and vertical. We didn't discuss the horizontal, but we discussed the vertical vessels, like the tanks for the vertical vessels. So I hope this point become clear now for you. You should get the top view and make the text is flipped, and by that way you will get the correct orientation. So you will need to have the top view on your drawing, as we did here, to get the correct orientation. It should be top here, top view, and the text is flipped. By that way you will get the correct orientation as you defined in SEG. Okay, I hope now this point become clear.
Okay.
Hello?
Okay.
Any other questions?
Well, we saw together how to today how we can make some general arrangement drawing. If we need detailed drawings for manholes, for clean outdoors, for nozzles, is it possible to create them from SEG, or we need to make them manually?
No, you can generate them from SEG directly. Regarding the clean outdoor, I send you an iLogic
Okay, yes, of course.
drawing, so we can use that. That will save a time for you during generating the details for the David. So from here, that was the clean outdoor drawing. So as you can see, a lot of details here. So if you use this iLogic model, it will save a time for you to add all of those dimensions and the bill of material for the items. And we will discuss that, inshallah, in another day of training.
Okay.
But some other details, like the bottom details or the roof structure. Regarding the roof structure, inshallah, after receiving the feedback from your side, we will prepare logic drawings for it, like this drawing. But for the bottom or the annular plates, for example, if you would like to add a detailed drawing for the annular plates, you can do that from here by selecting the annular plates from here, or the bottom plates, for example. So let's create a drawing for the bottom plates. Select the size of the drawing. Before that, let's open the bottom plates. Let's close this one. And let's open the bottom plates to check which view that we would like to use. So it's the back view. So we can use the back view to make it the elevation view. So from here, let's select the size, and from here select the elevation view, and from here let's select the back view. As mentioned, that back view, we will use it as the elevation. Okay, so let's select that one, and here the scale, let's keep everything as it is, and from here let's add the bill of material. Let's remove the nodes, and we can add some welding details. Let's remove that, and that, and from here we can select this detail, for example, that detail, okay, more that detail, and click on save. Now for the tables, let's name it as a bottom plate detail. And from here, give it a name like that. Add a revision table. Click save, add some empty rows, and from here, save that and click create drawing to start creating the bottom plate detail. And here's the bill of material. We can adjust the location and the scale of that one. So let's update the scale, minimize it a little bit. So from here, let's edit the drawing, and for the scale, let's make it 26, for example, and click on create drawing to be like that. And if you would like to add details for the other blades here, we can open this one and open this detail, this blade separately, and come back to the drawing and add a detail for this plate like that. So press that one, and now you can add the dimensions for this plate like that. Add another plate. So let's do this. From here, let's open that plate, for example, open. And from here, you can get a detail for this one. Move it and add the dimensions of this plate like that. Okay, so by that way, you can add each plate separately. And now let's move this one a little bit here to avoid clash with the border and title block. Like that. And you can add some center lines here. Here, that's the overlap. Like that. So by that way, you can generate the detailed drawing. Inshallah, we will discuss that in detail during the next training days, inshallah. But I still need the feedback from your side regarding the roof structure. Okay. To proceed accordingly with the application drawings of it and make it with iLogic to save time. And we still actually the last week we discussed some points regarding we can help you to generate the 3D models and application drawings for this project for all tanks. And we informed us that you can submit quotation or send us that, and we can prepare an offer or a proposal for you for the tanks to generate the 3D models and the drawings for it. For the BSG software, I asked you to send the finished items to study it, and you informed me that that week you will send some information. And for the roof structure, you will inform me that you will send me the feedback regarding the testing the 3D model of the roof structure.
Okay,
so
that's correct. I'll try to come back as soon as possible. We're not familiarized with using iLogic and Inventor, so we're having some, let's say, for the clean outdoor. Let me. Could you please? I will stop recording now.